uh, Avogadro number, just make sure that you write the power is 10 raised to the power of minus 23. So you write it in this scientific notation only. Fine.
Okay.
Your answer. Next is, how do you write the following? Again, can you see how do we write this in scientific notation?
Yes.
Is this clear?
Standard form. Yeah.
The number should be this, like you have 7.84. Now this 7 should, the first digit, that is like, which is before the decimal, should be between 1 or 9, right? 1 and 9.
Yeah.
It cannot be 0.84. Then you have to change it into 8.4 and then multiplied by 10 raised to the power of 10, right?
Okay.
10 is power of 1, or simply into 10, right? Now
Yeah.
uh, this part of how we convert or solve or simplify two decimal numbers, this is all the mathematical calculation, right? Suppose we have 10 raised to the power of 4 and 10 raised to the power of 6, right? So what we
Yeah.
do, we add the powers when the base is same, right? So 10
Right.
raised to the power of 4 and plus 6 also you'll get, do, so you'll get 10 is power of 10. But because when we are multiplying 1.38 into 8.21, we are not getting a number in the scientific notation. So when we write it in scientific notation, instead of writing 11.3, it becomes 1.13 into 10 is power of 11, right? Yes.
Yeah.
Is
Yeah.
this thing clear or not?
Yeah. Makes
Okay,
sense.
this is the common decimal prefixes. The most important thing is we should know about tera, giga, mega, kilo, hecto, and most importantly, these two come. Like micro, 10 is power of minus 6, nano, 10 is power of minus 9, and pico, 10 is power of minus 12. Okay,
Right.
in
Okay.
exams, they might not give you what is 1 nano equivalent to or 1 pico. So if you do not
Yeah.
write the prefixes correctly, then your answer will also be incorrect. So we have to remember this part also. Next,
Okay.
do you have any information, or have you ever done log any time in your classes?
No, we haven't done log. No.
Okay, basic ideas of log you should know, because what happens is, generally if they give you questions, they will give you the values of log in a bracket. But if you do not have any central idea, then you will have some problems. So it is better
Yeah.
that we should know. Why? Because see, if you do pH, we all know pH is minus log of H positive ions. Ever heard of this formula?
No.
Never. Now what is pH? pH is for acid. No, we know it is between
Yeah.
0 to 7, or right. So pH is the extent which tells us about the acidic character. But the most important thing is here, if I'm writing it inside the bracket H positive, what does this mean?
Oh, is that acid?
H positive means, yeah, H positive is H positive protons, H positive, right?
Yeah. Okay.
If it is a bracket, it means the concentration of H positive ions. Means we are talking about the molarity of H positive ions, or the concentration of H positive ions. Okay.
Okay. Okay. Okay.
So what is pH? pH is minus log of H positive ions. Means minus log. Log is a logarithmic, is a function. Now, what do we mean by function in mathematics? Function is an application of a certain thing. Now, see, I'll tell you why we are doing logarithm. What is the use of logs in mathematics? Suppose I tell you to give me the value of, say, 3. Okay, suppose say 3 raised to the power of 100. Okay, can you see this number written? 3 raised to the power of 100, right?
Yeah.
Now, what happens in this? Your work will be so much. Why? Because you will multiply 3 into 3 into 3 into 3 into till you get 100, right? Yes.
Yeah.
Now the most important thing is we are using the power. It gives the power to which the tenth must be raised. Suppose I'm writing suppose 1000. So I can write 1000 as 10 raised to the power of 3. Okay. So if I want to find the value of log base 10 of 1000, there is a property of log. I can write this 1000 as 10 raised to the power of 3. Can you see? Yes.
Yeah.
What is the power? Power is 3. So log has an identity that the power will come in the front. So we'll get 3 log 10 10. Okay. Now, whenever we have the base as 10 and here also written 10, this becomes equal to 1. Okay. Fine.
Right.
This whole entity will become 1. So 3 into 1 will become 3. Okay. So what is the
Right.
log of this number? It will be 3. Okay. I'm giving you one
Okay.
question. Just try this. Suppose I give you log of log base 10 and this is your number. Can you tell me what would be its value?
Would that be 1 second? It'd be log 10, 10 to the power of 5.
Yes. So they after this, what we should write?
5 log 10,
Mm-hmm.
and then 10,
Mm-hmm.
1.
Yeah, so this everything here will become 1, right? So it becomes 5 into 1 will be 5, right? Now the most important thing is why are we using log? I'll just write a note here. Okay.
Yeah.
Whenever we are writing logarithm, the exponent or the power to which a base must be raised to yield a given number. For example, if I say b raised to the power of x is equal to n. Now, I do not know how many times B is going to repeat itself to get a number n. To make the entire process easier, I take help of log. For example, okay, I'll give you an example. I know 2 raised to the power of 3 is 8. Yes, because it is a
Yeah.
small number, I know the fact. Right? I can
Yeah.
also write this as, therefore, we can say that 3 is the logarithm of 8. Okay, how do I write this? I'll say 3 is the logarithm of 8 to the base 2. Okay, to the base 2. Can you see? 2 is written raised to the power of
Yeah.
3. Okay, or some people can even say it as that 3 is equal to log base of 8. So these two things means the same thing. Okay, fine.
Okay. Yeah.
Now, why this becomes important? Here we know the values, they were very small. But if I tell you, suppose 2 raised to the power of some x is giving me some number n. Say that number is fictitiously, I'm giving you a number dash. I have so many digits it have. Okay, and this is your number, for example. Okay, now I have to report the value of x. Now in this case log will help us. Okay, so how we can calculate? We will write whatever the power x is coming, that will be log base 2 of the given number that we have. So in log we have a table which is already made. Okay, that log table will be provided, or they will give you the value of that log. So you just have to put that or substitute that value here and you will get your answer. So what does log do? It simplifies our work when the calculations or the number of digits are very, very high. Okay, clear?
Right.
Okay, okay. Next part. What is the natural log of the following numbers? This part, till here, we don't have to go into much of this complex thing, but the basics that you did, like you gave me an answer 5, till that level, it is sufficient. Okay. Now you can
Okay.
come to the next part, graphs. Now we know y is equal to mx plus c, where y is the y-intercept. Okay, here we're talking about the y-intercept, and this is the x-intercept, and m is the slope. Slope is m. Now, many a times, if they ask you what is the slope, it is change of y upon change of x. Okay, always
Yeah.
remember this formula. Next is, here it is also written y2 minus y1 upon x2 minus x1. Fine. Suppose they
Yeah.
have given you a graph. I'm drawing a graph. Suppose we have 2 comma 4. Suppose somewhere here this point is lying, and you have 5 comma 9, and they ask you what is the slope of these 2 points. Okay, so you will simply use the formula. This one becomes x1 comma y1. This becomes x2 comma y2. Right? So what are
Yeah.
we going to get? We'll use the same formula, y2 minus y1. Okay. What is y2 minus y1? 9 minus 4. And what is x2 minus x1? It is 5 minus 2. Right? That gives
Right.
us 5 by 3. So if somebody asks you what would be the slope, it will be 5 by 3. Whenever you have a slope, greater the slope, most steeper is your curve. Fine. Okay. Now what we are doing right now, we are knowing about the basics, because these small things will come in numericals. Do you know how to solve a quadratic equation?
Yes, but I don't think that's coming up.
Yeah, so you can skip this part, but you should know a bit. Okay, by middle term
Yeah, I
splitting
know
or
how
the
to do.
formula method. Okay, now you can simply come to this part. Calculate the mole.
Yeah,
Have
I'll read that. Yeah.
Okay, you can go through the remaining next 5 slides, then we will discuss.